Connect the apparatus as shown in this circuit diagram. This is a key K2, a resistance box called shunt resistance, a series resistance box, galvanometer, a key K2, power supply. Now take two copper wires, attach with galvanometer, one end of the galvanometer, one wire with resistance box connected in parallel. This resistance box is of 0 to 500 ohm. Its value is less than that of the series resistance box, and this series resistance box has a range of 0 to 10,000 ohms. After connecting these wires, take another copper wire, connect it with the shunt resistance and connect it with the one terminal of the key K2. Take another copper wire, connect the second terminal of key K2 with this wire and attach it with the galvanometer as shown in the figure. So this is how we are connecting the wire. Take another wire, attach this wire with the galvanometer and the key K1, and the one more copper wire connected with the second terminal of key K1 with the negative of the power supply. So the last connection is as shown. This is connected with the positive of the power supply with the one end of the resistance box. So after checking the connections tight, all the keys in resistance box, no key should be loose. Similarly, check the second resistance box, tight all the keys. After tightening all the keys, insert key K1 and that key K1 after inserting, we have to remove some resistance from the series resistance box to make maximum deflection. For that, remove some keys. So I am trying to get 30 divisions on the galvanometer, means maximum deflection. So note down the value from the resistance box: 5000, 2000, 500 and 200. So it is a total resistance of 7700 ohm. That is value of R, and theta is 30. Insert key K2. You will say a zero deflection in the galvanometer. It means circuit connections are okay. Remove keys from the shunt resistance box so as to make 15 divisions, means half deflection. And seeing the galvanometer, we have obtained 15 divisions. Note down the value from the shunt resistance box, that is 80. So calculate the value of galvanometer resistance using the formula Rs upon R minus S. You will get a value of 80 ohms resistance of the galvanometer. So let us reduce the deflection from 30 to 28, remove some more keys, increase the resistance, adjust the values, and you see here we have obtained 28 deflections, and note down the resistance from the resistance box, that is 8200. Now insert key K2, you will see automatically galvanometer is showing now 14 divisions. The shunt resistance remains same, that is 80. So 8200, 28 is a deflection, 14 is a half deflection, 80 is the shunt resistance, and use this formula again, Rs upon R minus S. This is again giving the value of 80 ohms for the galvanometer resistance. Now reduce 28 to 26, remove some more keys, adjust, and you see we have seen a 26 divisions. Again calculate the value from the resistance box. This time the value is 8800. From the series resistance box, deflection is 26, half deflection is 13. That we have to check after inserting the key K2. Automatically it is 13, and S remains the same, that is 80. So put these values in the table, 8800, 80, 26, 13, and again use this formula, G is equal to Rs upon R minus S. This gives the value equal to 80 ohm. So now take the mean of the galvanometer resistance, means add all three readings, 80 plus 80 plus 80 divided by 3, and this is the